maximum likelihood approach. Let the model be y is equal to beta x plus u, where u is normally distributed. So we need to transformation u to y. The assumption of multivariate density function for y, where y is equal to beta x plus u. Here py, suppose consider py is equal to pu multiplied mod of del u by del y. If del u by del y equal to 1, then pu equal to py. Here py is Pauli density function. If mod del y by del u by del y indicates the absolute value of determinant from the matrix of partial derivative, then del u1 by del y1, del u2 by del y1, del un divided by del y1, this is a matrix, and if del ui by del yi equal to 1, then the diagonals are all 1, and the off diagonal del uj by del yj it's equal to 0. So off diagonal terms are zero from this matrix, but this is an identity matrix, determinant equal to 1. For that reason we can write this is an identical matrix, so we can write that p of y is equal to pu, probability density function of y equal to probability density function of u. If we assume u is to be multivariate normal with mean vector 0, here consider mean is equal to 0 and variance is equal to sigma square. This is mean and this is variance. So P of u it's equal follow normal distribution, that is 1 by 2 pi sigma square power n by 2 e to the power minus 1 by 2 sigma square u prime u. That means we can write in this way that pu it's equal to and py it's equal to we know that u is equal to y minus y hat, where y hat is equal to x beta x beta. This is already mentioned here. So this improves both observation on y and Unknown parameter beta and sigma square. Writing probability of y is the form that L, likelihood of y, two parameter, that is beta and sigma square. Here we choose the parameter like beta and sigma square. In this way, the estimated y tends to maximum likelihood, and second order condition of maximum likelihood estimation will be less than 0, and maximum likelihood function will be concave. But in Wales, our objective is minimize the error term. We try to minimize this one, y minus y hat. But in MLE, our objective is to choose beta and sigma square in such a way that this L follow the maximum likelihood so that y is equal to y hat. Original equal to estimated in the MLE. So Ly beta sigma square, this emphasizes that it is the probability density for y. Which one? L first bracket y beta sigma square is a probability density for y given the parameter beta and sigma square. The meaning of this Ly beta sigma square is that it is a probability density function for y given beta and sigma as a parameter. Alternatively, we can write L beta sigma this stress the fact that for given y, it can be regarded as a function of parameter. It is termed the likelihood function and it's conveniently denoted by a likelihood function. L means likelihood. L means likelihood. So we can represent likelihood in this way as well as in this way. L y beta sigma square or L beta sigma square y. The maximum likelihood principle is to choose for the estimators of beta and sigma square the value which maximize likelihood function given the sample data. I already mentioned that given the sample data, maximum likelihood principle to choose estimators like beta and sigma square in such a way which maximize the likelihood function, which maximize the L function. Given estimator beta and sigma square. So letting theta prime is considered as here, theta prime is there. Theta prime is equal to beta prime sigma square denotes the vector of unknown parameter theta prime is the maximum likelihood. It is also called theta prime. This theta prime. It's also called the maximum likelihood estimator. Theta prime is obtained as the solution from the equation del ln L by del theta. It's equal to 0. First order condition is equal to 0. So we can write first order condition in such a way that del L by del theta. Taking derivative with the maximum likelihood function, first 1 by L, we taking log and then del L by del theta. So first order condition, that is why it is equal to 0. Taking log on both sides. Which equation? The equation is y minus x beta whole prime, y minus x beta divided by 2 sigma square. So taking log both side. Taking log both side, we get log of L is equal to minus n by 2 log of 2 pi minus n by 2 log of sigma square. It is equal to minus 1 by 2 sigma square, and then y minus x beta prime whole prime y minus x beta. So that is already there in the class notes, that is here. Del log L, it's equal to log L minus n by 2 log 2 pi minus n by 2 log sigma square minus 1 by 2 sigma square u prime u, and del log L taking derivative with respect to parameter beta, that is del log L with respect to del beta is equal to minus n2 sigma hat square. This estimated, that is why sigma hat minus 2. It is better if I follow the steps. Check. Minus n by 2 sigma square, sigma hat square. Only the last term has sigma, that is why the other terms will be 0. derivative with respect to beta. So beta only in the last term. So first is better if I write down all those steps here. Minus, if I multiply, first term will be 0, then 0. For this one, that is also 0. But for this one, there is a beta term, so the derivative will be there. We can write there will be a prime here. So if we add this y, x prime, beta prime, y plus, I need to write here, these two term and this one, x prime, beta prime, y minus x beta prime y. So if we add, then get minus 2 x prime beta prime y or x y beta prime. Then it is better to get the result. Then taking derivative in the next page, and then get del log L by del beta, it's equal to 2 sigma hat square first bracket, minus sign is there, I made a little mistake from this equation. So from the likelihood function, we are taking derivative with respect to beta and sigma square. There is all steps are not clear. So if all the steps need to clear, so I mention all the steps in the next slide. That is, log L is equal to minus n by 2 log 2 pi minus 2 by n log sigma square minus 1 by 2 sigma square u prime u, or we can say prime e, and the next minus n by 2 log 2 pi minus n by 2 log sigma square minus 1 by 2 sigma square y prime y. Just breaking the bracket and multiply minus 2 sigma all these terms and get minus 1 by 2 sigma square y prime y. Here minus 1 by 2 sigma square y prime x beta minus x prime x prime beta prime y plus x prime x beta square. And then it's better to check derivative with respect to beta and sigma square. And we know the maximum likelihood condition is first order condition will be 0. So after taking derivative, we are setting the equation will be equal to 0. And before going to that proceed, we will just add this term. Which one? This is the second. Here the second and third term. These two terms. And get 2 x prime y beta multiplied with 1 by minus 1 by sigma square, and taking derivative with respect to beta and get minus 1 by 2 sigma square. First bracket minus 2 x prime y plus 2 x prime x beta hat. Here beta is estimated, that is why beta hat, and 1 by 2 sigma hat square. Sigma hat is also estimated in the next line. So 2 common, and in the bracket term there is x prime y minus x prime x beta hat. It's equal to 0, and x prime y it's equal to x prime x beta, this term and this term, it's equal to beta hat, and then x prime x whole inverse into x prime or transpose y. And after taking derivative with respect to beta, then we are taking derivative with respect to the parameter sigma hat, sigma square. And before going to that derivative, just rewrite the equation. Log L likelihood function is written here, or likelihood equation is written here once again, and then taking derivative del log L with respect to del sigma square is equal to minus n by 2 sigma hat square. Sigma hat is estimated, and minus of, because here 1 by 2 sigma square, taking log, that is why minus of 1 by 2 sigma power 4 sigma hat power 4, and the other term is same here. And then del log L by del sigma square is equal to minus n by 2 sigma hat square plus minus 2 minus is there, that is why plus 1 by 2 sigma hat power 4 into rest of the terms same, and setting equal to 0 because of first order condition, maximum likelihood condition. And then taking common outside 1 by 2 sigma hat square, and in the bracket term there is only n minus 1 by sigma hat square e prime e means here x minus y minus x beta hat prime, that is e prime, and y minus x beta hat is equal to E, and if we take 2 sigma hat square in the right hand side, that will be equal to 0. So n is equal to sigma hat square E transpose E equal to E transpose E equal to sigma hat square divided by n. But the problem is beta hat well is equal to beta hat maximum likelihood estimation, but sigma hat well is not equal to sigma hat maximum likelihood estimation. So it is only possible, but MLE of sigma hat square is bias estimator, but it is consistent estimator. Obviously, beta hat well is it's not equal to beta hat MLE, and here we get beta hat MLE is E prime E divided by n, but in case of Welles it is equal to E prime E divided by n minus 2, but only here we only get MLE, then there we get E prime E, it's n, the terms are not equal. MLE it's bias estimator by the factor so there is a difference between beta hat OLS, that is unbiased, but beta hat MLE it's unbiased. If n tends to infinity, then maximum likelihood condition of beta hat square and ordinary least square estimation of maximum likelihood condition of sigma hat square and ordinary least square technique of sigma hat square will be equal, but there is no problem with the term beta. So the brief description is already there. Thank you.